Ethereum may be unrecognizable 3 years from now. In February, Vitalik Buterin admitted that Ethereum's current roadmap no longer makes sense. So now Ethereum is planning to replace every major component and rebuild the entire network while it continues processing billions of dollars in transactions every day without stopping. The goal is to take Ethereum from around 30 transactions per second with 16-minute finality to 10,000 transactions per second with 8-second finality, while scaling layer 2 capacity to handle around 10 million transactions per second across all rollups. They're also migrating to quantum-resistant cryptography and adding native privacy. So here's how they're planning to pull this off and what it means for you. Ethereum's original scaling strategy was simple. Layer 2 rollups would handle user activity, while Ethereum stayed as the secure L1 transactions would settle on. And for a while, this worked, or looked like it did. Layer 2 usage exploded, fees dropped to pennies. But then, in February, Vitalik wrote a pointed statement about how L2s that were mediated by multi-sig bridges weren't really scaling Ethereum. That's most L2s today. So what he's saying is that real scaling means the layer 2 has to be genuinely secured by Ethereum's validators, not just connected through a bridge controlled by a few people. Otherwise, you've just built a fast centralized chain, borrowing Ethereum's name without inheriting its security. So 3 weeks after that post, the Ethereum Foundation proposed the straw map, 7 upgrades across 3 years to fix 5 specific problems. The first problem is speed. When you send a transaction on Ethereum, it takes about 16 minutes before it's permanently irreversible after multiple rounds of validator confirmations. But 16 minutes makes Ethereum unusable for applications such as instant payments and high-speed trading. The first upgrade, Glamsterdam, in early 2026, introduces block access lists. Ethereum currently processes transactions sequentially. Even independent transactions wait in a single queue. So block access lists let independent transactions run at the same time instead of waiting in a queue. The network can suddenly process significantly more transactions in the same amount of time, which means more supply of block space and fees should drop significantly. Through 2027 and 2028, more upgrades stack on top of this. They shrink the time it takes to create each new block, from 12 seconds today down to 2 seconds. Faster blocks means faster confirmations. They also replace how validators reach consensus with something called Minimit, which finalizes transactions in one voting round instead of the current system that requires multiple rounds of back and forth confirmation. Now, the biggest transformation comes in late 2028 with zero-knowledge proofs integrated into Ethereum's core. And this fundamentally changes how the network verifies transactions. Right now, every node re-executes every transaction to verify it. It's kind of like checking someone's math homework by redoing every problem yourself. Now, with zero-knowledge proofs, nodes verify a compact cryptographic proof instead, which confirms the work is correct, making it orders of magnitude faster. And this is what unlocks 10,000 transactions per second and drops finality from 16 minutes to 8 seconds. Now, speed isn't enough if only data centers can afford to run nodes. Running an Ethereum node today requires serious hardware and storage capacity, and that cost means validation concentrates among organizations with infrastructure budgets. And the more this happens, the less decentralized Ethereum becomes. So, the second upgrade, Hegota, in late 2026, switches to Verkle trees, a more efficient way to organize Ethereum state data. When you validate a transaction today, you need a proof that it's about 1 kilobyte. Verkle trees compress that down to less than 150 bytes. That's small enough that you don't need to store Ethereum's entire history locally. You can validate blocks using just the data included in the block itself. And those zero-knowledge proofs from late 2028 compound this benefit. If nodes verify cryptographic proofs instead of re-executing thousands of transactions, computational requirements drop dramatically. So put both together, and by 2029, running an Ethereum node becomes possible on regular consumer hardware. The easier it is to run a node, the more people can participate in securing the network. And then there's the economics problem. Before Denken in 2024, Layer 2s paid about 41% of their revenue as fees to Ethereum when posting data. Denken made data storage cheaper. Great for users, but fees dropped to less than 10% of Layer 2 revenue. Ethereum burns those fees, permanently destroying them. At the same time, Ethereum issues new ETH to validators. When burn exceeds issuance, ETH is deflationary. When it doesn't, ETH supply grows. With fees this low, the burn can't keep up. ETH has now become slightly inflationary. So the roadmap solves this from both directions. Glamsterdam makes Ethereum's mainnet faster and cheaper. Each block has a limit on how much computational work it can process, and that's currently set at 60 million gas units. Glamsterdam raises this to over 100 million, which means each block can handle significantly more transactions. And some applications won't need Layer 2s at all, bringing fees back to mainnet. But Layer 2s will always be cheaper for certain use cases. So the other direction is scaling Layer 2 data capacity. Layer 2s post compressed transaction data to Ethereum in chunks called blobs, and right now there are about 14 blobs per block. The roadmap scales this dramatically higher. At that scale, Layer 2s process millions of transactions per second. Even if each transaction pays only a fraction of what it used to, millions of transactions per second means the total burn can keep up with issuance. Now, the fourth problem is centralized block production. About 90% of Ethereum blocks are built by a handful of private relay companies. Validators are supposed to decide which transactions get included in blocks, but most have outsourced this to specialized block builders. And these builders package transactions to maximize their own profit, which means they can front-run trades, censor specific addresses, or exclude transactions that they don't like. And all their blocks flow through a few relay companies that act as gatekeepers. So Glamsterdam and Heygoda fix this in 2 steps. Glamsterdam moves block building directly into Ethereum's protocol, eliminating the private relay gatekeepers. Heygoda gives validators the power to force transactions into blocks. Even if a block builder tries to censor something, validators can override that decision. And by the end of 2026, block production becomes credibly neutral again. And none of this matters if the network becomes obsolete. There is about a 20% probability quantum computers powerful enough to break Ethereum's current cryptography arrive by 2030. And then there's also privacy. Every Ethereum transaction is completely public, which means businesses can't operate where competitors see every financial move. Starting with Heygoda in late 2026, Ethereum could begin switching to cryptography that quantum computers can't break. This happens gradually across upgrades through 2029 using hash-based algorithms instead of the current system. Now, the rollout prioritizes the most critical parts first. So even if quantum computers arrive early, Ethereum keeps running. They're also adding native privacy. Right now, when you send ETH, everyone can see your address, your balance, and your transaction history. The privacy upgrade lets you send ETH through a shielded pool that hides these details. Only you and the recipient know what happened. Now here's what this comes down to. Can Ethereum ship one upgrade every 6 months for the next 3 years through decentralized governance? And will the community even approve all this? Ethereum's never shipped a multi-year plan on time. The merge was supposed to happen in 2019. It shipped in 2022, and that was one upgrade. But this is not 2022. So could AI perhaps help accelerate how fast they ship? Well, if Ethereum delivers this roadmap, it becomes the first blockchain with institutional grade performance and also credible decentralization. So what do you think? Will they pull it off?